All right, in today's worksheet that I gave out today in class, we're going to go ahead and go through 1 through 12. Now, on number 1, it says y equals 3 secant theta. And the first thing we're going to do is graph y equals 3 cosine theta, because remember, the secant of theta equals 1 over cosine theta. So we're going to graph the cosine first and then make our parabolas very last. So when we look through this, we always want to write out what is our amplitude. Our amplitude is the number that's in front of the cosine, so our amplitude is 3. To find our period, we take 2 pi divided by omega, which is the number in front of theta here, which is 1. So it's 2 pi divided by 1, which is 2 pi. We don't have anything added inside the function, nor do we have anything outside the function, so that's all we have. Now, remember that's going to be 2 pi times 0, 2 pi times 1/4, 2 pi times 1/2, 2 pi times 3/4, and 2 pi times 1. Give us 0, pi over 2, pi, 3 pi over 2, and 2 pi as our 5 points within the period. So we'll be at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, we didn't have a vertical shift, so our midline will stay right there on the x-axis. Now, we did have an amplitude of 3, so that means from the midline we'll go up 3 and down 3. I like to circle that number so it reminds me of where my top amplitude point and my bottom amplitude point will lie. Now we look back and I've got to graph the cosine. Now remember, the cosine function will start at our starting point at the top amplitude. Then the next point it hits our midline. Then we go to the bottom amplitude, midline, and top amplitude. We connect our points by curving through the points because it is a wave. Now we need a graph in our asymptotes. Now our asymptotes are going to be everywhere that the midline and the point of the graph crosses. So we'll have one at pi over 2, and we'll have another one at 3 pi over 2. Now to graph the cosecant function, what we will do is we will take our maximum endpoints here. We have a maximum, and we make our parabola. We have a minimum. We make our parabola within our asymptotes. We have another maximum, and we make our other parabola. Now, remember that to graph this truthfully all the way through, we would need to go and erase away our cosine function, and we would just be left with our half parabola here, our full parabola down here, and our top parabola half here, going on one period from 0 to 2 pi. Now we're going to graph number 2, y equals 2 secant theta. Now remember, secant theta goes with 1 over cosine theta. So we're going to graph the cosine of this function, so y equals 2 cosine theta. Now the number in front of the cosine, remember here, is our amplitude. So that'll be 2. To get our period, we take the number that's in front of theta. We take 2 pi divided by that number, which is 1, which gives us 2 pi, and that is our period. Now, just like in number 1, we're going to have our 5 points as being 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, there is no number on the outside beyond theta being added or subtracted, so our midline will stay on the x-axis. So that'll be our midline. Now, our amplitude is 2, so that means we have to go up and down an amplitude of 2 from that midline. Now it is the cosine function again, so we're going to start up at our top amplitude for our first point. Our second point, we hit our midline. Third point, bottom of our amplitude. Next point, midline, and last point, the top of our amplitude. We connect them by curving through them, and that gives us one period of our cosine function. Since we need the secant function, we need to draw in our asymptotes again at wherever our cosine function crosses the midline. So here's our asymptotes. Now we need to make in our parabolas. At this maximum point, we go towards our asymptotes on each side. And that gives us our secant function, except for we need to take our eraser and go through and erase away our cosine function, because we do not want that part of our graph, and then fill in our sketch so we can have y equals 2 secant theta. Now for number 3, we have y equals negative 3 secant theta plus 1. We need to change this over to a sine or cosine function to graph it. First, remember the secant. We're going to use y equals negative 3 cosine theta plus 1. Again, labeling in our amplitude, which is here. So our amplitude is 3. Our period, again, is going to be 2 pi, because the number in front of theta here is 1. And remember, it's 2 pi divided by 1. Now, outside our theta, we have a 1 out here. That's going to be a vertical shift. Because it is positive, we'll have a vertical shift of up 1. Now, let's go ahead and graph what we have here. So I'm going to go ahead and graph my vertical shift up 1. Now remember, our midline on our original function starts at the x-axis. Moving up 1 puts us up on the line y equals 1. Now we have an amplitude of 3. So going up 1, 2, 3, down 1, 2, 3 gives us our top amplitude and bottom amplitude. Our period again is 2 pi, so we'll be at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, remember here that we have a negative sign out front. So instead of starting at the top amplitude, we will start at the bottom amplitude. So when I graph this in, we start at the bottom amplitude. Next point, we hit our midline. Top amplitude, midline, bottom amplitude. And again, we curve through the points because we are a cosine function and we are a wave. Now again, our asymptotes are going to lie wherever the cosine function hits our midline. So we'll have one at pi over 2 and another asymptote at 3 pi over 2. Again, we need to draw in our parabolas. Now, the black line that represents the cosine function, remember, that's a cosine function. That's not a secant function. So we need to take our eraser and erase away that cosine function, which helped us graph the secant function, and we're left with the graph that looks like this. Now, as we graph number 4, y equals 2 cosecant 2 theta. Now, remember, cosecant goes with the sine, so we're going to graph y equals sine 2 theta. Now, remember, our amplitude here is going to be 2. Now, our period is 2 pi divided by omega. And remember, omega is that number in front of that theta. So it's going to be 2 pi divided by 2, which is going to give us pi because the 2's are going to cancel out. Now that's going to change our points on the graph. Now putting it into our table, our period is pi. And remember, we always multiply that by 0, then 1/4, then 1/2, then 3/4, then 1. So that'll give us 0, pi over 4, pi over 2, 3 pi over 4, and pi. And those will be our 5 points on one period. So we'll have 0, pi over 4, pi over 2, 3 pi over 4, and pi. Those will be my 5 notches or my 5x points. Now, there was no vertical shift, so our midline still is on the x-axis, and that's going to be, remember, the midline. Now, the amplitude is 2, so that means we need to go up 2 and down 2 from that midline. Now, we're graphing the sine. Remember back to the parent function of the sine. The sine starts at the midline. Then it goes to our top amplitude, which is 2, and our bottom amplitude, which is going to be -2. So we start at the midline. Next point, we go up to our top amplitude, then back down to our midline, then down to our bottom amplitude, up to our midline. And remember, it's going to be a wave, so we need to curve through each point. Now, we're not graphing the sine, we're graphing the cosecant. So we need to put in our asymptotes. That's everywhere, just like with the cosine graph that we graphed for the secant. The cosecant works the same way. Wherever those points hit that midline is going to make an asymptote. That's not going to change. Now we take our max and min points and we make our parabolas. We take our eraser and we erase away the sine function, leaving us just with the cosecant function. And if you notice, our points here of our parabolas are going to be the same spot as our amplitude, the top amplitude and the bottom amplitude, leaving our asymptotes, our midline, and our parabolas. That gives us y equals 2 cosecant 2 theta. Now, graphing number 5, y equals 3 cosecant theta over 3. Now, remember, cosecant goes with sine, so we're going to graph 3 sine theta divided by 3. Again, the number in front of the sine gives us our amplitude, so that gives us 3. Now, for our period, remember, that's 2 pi divided by omega. Now, the number in front of theta is 1 again, so the number here is 1/3. So that omega is 1/3. So that's 2 pi divided by 1/3. 2 pi divided by 1/3. Copy, change, flip gives us 6 pi for our period. So our period is 6 pi. Filling it into our table. And when we multiply 6 pi times 0, we will get 0. When we take 6 pi times 1/4, we will get 3 pi divided by 2. Half of 6 pi is 3 pi. 6 pi times 3/4 is 9 pi divided by 2. And 6 pi times 1 is 6 pi. So now we need to plot those points. 0. 3 pi over 2 is 1 1/2 pi, so 3 pi divided by 2. 3 pi, 9 pi divided by 2, and 6 pi. We have no vertical shift here, so again, our midline will be right there on the x-axis. Our amplitude is 3, so we need to go up 3 and down 3. So up 3, 1, 2, 3, down 1, 2, 3. So it gives us our top amplitude and our bottom amplitude points. Now, we're graphing sine. Sine starts on our first point. on the midline. Next point, it goes to the top amplitude, midline, bottom amplitude, midline, waving through the points. We'll just make that one a little bit bigger. Now, we need to draw in our asymptotes. Everywhere our points hit the midline, our graph crosses our midline. We'll graph those in. Then we'll take each one of our points and make our parabolas. Now remember, these are going to be the points that are at the top of our amplitude and the bottom of our amplitude. We take our eraser and we erase away the sine function, leaving us with one period of our 3 cosecant 3, theta over 3. All right, now let's look at number 6. Y equals 2 secant theta plus pi over 2. Now, when we graph this one, our amplitude is going to be 2. Our period is still that number in front of theta divided by 2, so that's 2 pi divided by 1, which is just going to give us 2 pi. Now this one, we have a phase shift. Now for the phase shift, we take our number being added to theta inside the parentheses. We change the sign. So we're going to make it negative pi divided by 2. And we take that number in front of theta and we divide negative pi over 2 divided by 1, which our phase shift is just going to be negative pi divided by 2. So filling out our table, our phase shift would be negative pi divided by 2 for each one of the spots. Now our phase shift, or our period, is 2 pi. So now, working through the table, I'm just going to go ahead and write down what it all equals. When you multiply this out and you work it out, we're going to get negative pi divided by 2, 0, pi divided by 2, pi, and 3 pi divided by 2. Now, how did I get that? Well, let's take this, and I'm going to take the camera down here. It's going to pop up, and with this camera, it's going to take us to a new slide. Now, on this new slide, I'll work it out and show you how I did this. 2 pi times 0 plus negative pi divided by 2. Well, that's going to be 2 pi times 0 is 0 plus negative pi divided by 2. Well, that just gives us negative pi over 2. So we have that one. Now, if we look at the next one, 2 pi times 1/4 plus negative pi divided by 2. Now, when I work this out, remember, we multiply straight across. So that's going to give me 2 pi divided by 4 plus negative pi divided by 2. Now, because I need common denominators, and I know I can simplify 2 pi divided by 2, I can write that as pi divided by 2 plus negative pi divided by 2, which gives me 0. Working out the next spot, 2 pi times 1/2 plus negative pi divided by 2. That's going to give me 2 pi divided by 2 plus negative pi divided by 2, which is going to give me 2 minus 1, which is 1, so it's just going to give me pi divided by 2. Now we need to take 2 pi and multiply it by 3/4. So we're going to take 2 pi times 3/4 plus negative pi divided by 2. Well, that's going to give me 6 pi divided by 4 plus negative pi divided by 2. Now when I work this out, I know that 6 over 4 gives me 3 over 2 plus negative pi over 2. 3 minus 1 is 2, so I get 2 pi divided by 2. 2's cancel out, so I'm just left with pi. Scrolling back up to the top, I have my pi. Now I'm just going to work the last one out right up here, so I have 2 pi times 1 plus negative pi divided by 2. So it gives me just 2 pi plus negative pi divided by 2. Well, 2 is the same thing as 2 over 1. I need a common denominator. These two numbers are not the same. So multiply the top and the bottom by 2, and I'm going to get 4 pi divided by 2 minus pi divided by 2, because positive and a negative gives me a negative, which gives me 3 pi divided by 2, or 3 pi over 2. So I have all my 5 points. Now we're going to scroll back and go to the previous slide so we can finish our problem. Now, we have no vertical shift. So remember, that gives me my midline still at the x-axis. Looking at the amplitude next, that's up 2 and down 2. Up 2, down 2. Now, I need to know where are my points that I'm going to make my graph go through. Well, my first point has to be at negative pi divided by 2. My next point is at 0. The next one's at pi over 2, pi, and 3 pi over 2. So on this one, we had to make an extra point on the left side of that y-axis. So because of that, I'm going to pull back my numbers here a little bit so that we can see that point a little bit better. Now, when I graph this through, I've got to graph the cosine function. The cosine function is going to start up at the top amplitude, hit the midline, bottom amplitude, midline, top amplitude. So I'm just going to take my pen and make a wave through it. Now remember, wherever my graph hits that midline, these spots here, that's going to be our asymptotes. So I make my asymptotes. Now I'm going to take and finish my problem by making my parabolas at the max and min points, or where the points are at my bottom amplitude and top amplitude. And over here, I can't forget this last one, and I need to make that half. Taking my eraser, I erase away my cosine function that I made to help me graph, and I leave it just like that. And that is y equals 2 secant theta plus pi over 2.